Hi everyone, this video is going to go over valence electrons and Lewis dot diagrams. So by the time you are done with this video, you can look at any main group element and figure out how many valence electrons it has, as well as how that looks on a Lewis dot diagram. So let's jump in and talk about some valence electrons. So first up, valence electrons are electrons on the outermost energy level of an atom. So these are the ones on the outside, and because these electrons are on the outside, they have a special job, we could call it, compared to other electrons on the inside. So because these electrons are on the outside, that makes them able to interact with other atoms. And as they're interacting with other atoms, that means they're responsible for chemical bonding. And we're going to spend a whole unit on chemical bonding. So we're really going to talk about valence electrons then. But these electrons are on the outside. They interact with the other atoms, and they're responsible for chemical bonding. So what that looks like, let's say we had an atom of, let's say this is beryllium, Be. Beryllium on the periodic table has a mass of 9 and atomic number of 4. So we're just going to zoom in on the electrons. So there's 4 electrons for beryllium. You know that on a Bohr model, there's 2 on that first level, and then we're going to have 2 on that second energy level. So the valence electrons then would be here and here. So those are the valence electrons for beryllium. We could also show the valence electrons another way. If we were to write out the electron configuration of beryllium, which is 1s2, 2s2, we go to the highest energy level right there, being 2, and we can see the electrons that way as well. So our valence electrons could be represented that way too. Let me show you one more. Let's look at fluorine. Fluorine has a mass of 19 and atomic number of 9. So if we're putting 9 electrons on here, 2 go on the first, and now we have 7 more to go on the next. So 1, 2, 3, 4, 5, 6, 7, which means fluorine has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. So those are all the valence electrons. If we were to write out the electron configuration for fluorine, it would look like this. So to show the valence electrons this way, our second energy level is split up into 2 parts. We've got 2s and 2p. These are both part of the second energy level though. So we take 2 and 5, and those are our valence electrons as well. You might be wondering about the other electrons. If the ones on the outside are valence electrons, well, what about the electrons on the inside? The electrons on the inside are called inner electrons or core electrons. And those would be just the electrons on the inside, like this one and that one. Those would be inner or core electrons. So just by looking at the periodic table, you can find out how many valence electrons there are. And it works by group, by column. Everything in the first column just has 1 valence electron. And if you want to try it out to test it, you can. So hydrogen is 1s1. Below that is lithium, which is 1s2, 2s1, and so on and so forth. All the way even down to francium. Francium ends with 7s1, and that superscript 1, that would be your valence electron. Or if we drew Bohr models for all of these, we would see that on the very outside, we only had 1 electron. Group number 2 will have 2 valence electrons. We're going to skip the D and F block. We'll come back to that later. Let's go over to group 13. Group 13 has 3 valence electrons. Boron is 1s2, 2s2, 2p1. So if it's 1s2, 2s2, 2p1, then 2 plus 1 would be 3. And that'll be true for all of these. So this column has 3. The next column, group 14, has 4. Group 15 is next, so you could make a prediction then, I'm sure by the pattern now. Group 15 has 5. Group 16 has 6. 17 has 7. And group 18, all except 1, have 8 valence electrons. Our exception is helium. Helium only has 2 valence electrons because helium's electron configuration is 1s2. It's very small, kind of defies the rules a little bit there. But everything else in that group has 8. Right here, we have neon, 1s2, 2s2, 2p6. It has 8. And that'll be true all the way down for those. Okay, so we skipped the D block and the F block, and there's a reason for that. So the D and F block, we are skipping because they are considered to be polyvalent. The prefix poly means many, and valent referring to valence electrons. So something like copper right here, it could have a number of different valence electrons. It just depends on the atom. They don't follow a strict pattern like these main group elements do. So groups 1, 2, and groups 13 through 18. It will pretty much follow that pattern. So take a second, let's quiz ourselves, make sure we're understanding. Okay, so let's say I wanted to know how many valence electrons sulfur had. Sulfur is right here. It's in group 16, so it's gonna have 6 valence electrons. Or let's say we were asking about barium right here. Barium is in the second group. It'll have 2 valence electrons. So on your periodic table, if you would like to, you can label your valence electrons like this. And that might be a little bit easier to see as well. So if you want to grab your periodic table, you can go ahead and label it. Just remember these and these are polyvalent, so we're going to ignore them for now. All right, let's move on and start talking about how to draw Lewis dot diagrams. So for a Lewis dot diagram, all that we're really doing is showing valence electrons as dots, but in a different way than Bohr's model. Lewis dot diagrams are used eventually to show structures of molecules. But first, we just want to look at the valence electrons of our atoms. So to draw a Lewis dot diagram, the first step is you write the element symbol in the middle. So while we go over the steps, let's do an example together. So we're going to look at nitrogen for our example. So step 1, draw the symbol in the middle. There we go, there's nitrogen. Step 2, we need to determine how many valence electrons nitrogen has. Let's take a look at our periodic table. Nitrogen is here, so it has 5 valence electrons. Okay, we figured out it has 5 valence electrons. Number 3 is we have to place in the correct order these dots. In the order, it doesn't matter where you start on the side, but you have to make sure every side has a single dot before pairing, which probably sounds similar to your orbital diagrams. So imagine that this is really in a box. You can only put dots on the sides of the box. You cannot leave dots hanging out to the side like this or like this. Everything needs to be very close to that box. So here's how the order goes. You can start on any side of the box you would like, but your first dot will go here, then your second, third, fourth. So now every side of the box has a single dot before pairing up. To go back and pair up, then we would put 5th, 6th, 7th, and 8th. It doesn't matter where you start. Some teachers get really hung up on this, but honestly it doesn't matter and they can be manipulated. If you want to start number 1 over here, that's awesome. If you would prefer, you can even start number 1 here and go 1, 2, 3, 4, 5, 6, 7, 8. It doesn't matter which side you put that first one on, just make sure every single one has a single dot before pairing. So for our example, nitrogen had 5 valence electrons. So we go 1, 2, 3, 4, and now we pair up 5. So it could look like that. Or if we started in a different place, like let's say we started on this side, we could go 1, 2, 3, 4, 5. Doesn't matter where you start, but notice that every single one had a single dot before we paired them up. Let's do another example together. Let's work on chlorine. So chlorine, go ahead and go through those steps 1 through 3 to try to draw a Lewis dot diagram of chlorine. You can pause the video. Okay, so chlorine, the symbol is Cl. and you found it on the periodic table right here. So you notice it has 7 valence electrons. So now that we know that, we're going to place them in the correct order. We can start on any side we want. I'm going to start over here this time. 1, 2, 3, 4, 5, 6, 7. And that's what it should look like. Things that Lewis dot diagram should not look like. You should never have something like this. Nope. That is not good. We cannot have these electrons out there floating around. They have to be tucked neatly against the side of the box. So we can't have electrons floating out like that. So watch that very carefully. Sometimes people like to draw them like that. Can't draw them like that. It has to be neatly against the side there. Whenever you have electrons paired up, they do have a special name. It's not a very creative name. They are called lone pairs. So if you have an element like nitrogen, this is a lone pair on nitrogen. So a lone pair, we've just got 2 electrons next to each other. So nitrogen has 1 lone pair. Chlorine would have 3 lone pairs. Okay, let's take a second and have you do some practice problems. Make sure you're understanding. So we're gonna do just a few of these. You can pause the video, try them out, and then we'll go over them. Okay, here are your problems. So for numbers 1 through 5, you're just gonna draw some Lewis dot diagrams of those. So on your paper, you can turn this one over or off to the side. Just practice these 5 problems of Lewis dot diagrams. And then question number 6, a little bit more difficult. To what group does this element belong? So we can see this Lewis dot diagram right here. What group number on the periodic table should that belong to? Go ahead and pause the video and give them a try. All right, let's go over these. So number 1, potassium is in the first group. It only has 1 dot. And depending on where you drew the dot, it might be on this side, or you might have it up here, or maybe you drew it on the bottom. That's absolutely fine, as long as it has 1 dot. Next is phosphorus. Phosphorus is here. It has 5 valence electrons. Start wherever you'd like. 1, 2, 3, 4, 5. So 3 of your sides should have a single dot. 1 of them should be matched up. Xenon is here. It has 8. So 1, 2, 3, 4, 5, 6, 7, 8. Xenon has 8. Number 4 was calcium. Calcium has 2. Doesn't matter where you start. You could start here and go 1, 2. You could even have as an answer technically something like this or something like this. There are lots of possibilities just as long as they're on separate sides. Next is carbon. Carbon right here, group 14. It has 4. Start wherever you'd like. 1, 2, 3, 4. And our last question, question number 6, to what element does this, to what group does this element belong? So we can see here, there are 1, 2, 3, 4, 5, 6 valence electrons. So we need to find a group with 6 valence electrons. There's only one group that all has 6 valence electrons, and that is group number 16. So the answer for question number 6, this has to belong to group 16. Okay, so now you know what exactly a valence electron is, how to look at the periodic table, figure out how many valence electrons it has, and then you are able to draw a Lewis dot diagram representing those valence electrons. That's it for the notes.